Hello, bachas. Welcome back to the channel, the F in Physics, where the F in Physics stands for fun. So, winter 2022 is finally out, and I saw the MCQ paper variant 2, and I've got a list of questions, four of them, which I thought a few kids might face difficulty in solving. So, let's go through them. Here it is, the first question, question number 30. Each potential divider is placed in a circuit with a power supply. So this is some part of the circuit, and these are the two resistors which are acting as potential dividers. Potential divider matlab they share the voltage of the supply. Which potential divider makes the potential difference across component Y increase? So if you look, there is a resistor which is marked as component Y. So you need a greater voltage over there. Okay, which means voltage at X should be less, which means resistance of X should be less basically, because voltage is proportional to resistance. When the light intensity increases, so I know I am varying light intensity. So if you look at the options, you can straight away eliminate C and D, because you have thermistors over here, they depend on temperature, which means my answer for sure is either A or B. So if I look at A, I know my voltage at X should decrease, which means resistance of X should be less. So if I read the question, I know light is increasing. So if I look at A, as light increases, my X is an LDR, which means resistance of X will decrease, which means voltage of X will reduce, thus voltage of Y will be higher. So this, I believe, matches with this statement. So A looks good. If I go for B, again I use the same logic. If my light increases, so for B I'll write the explanation over here. If my light increases, I know the resistance decreases, which means now, because my LDR is at Y, voltage at Y will decrease, which is opposite to what is required. And thus my answer for 30 is going to be A. Then I move on to 31. Now this was a good question. Okay, now this is how full wave rectifiers work, but you don't need to know what full wave rectifier is. You only need to know how a diode works. So a diode will work in the forward bias condition, which means when the conventional current is moving from the positive of the diode to the negative of the diode. Okay, so diagram 1 is a circuit diagram showing an AC power supply. It's AC, which means let's assume initial phase mein the top part is positive, bottom is negative. After one complete cycle, the polarities flip. Okay, diagram 2 shows the output voltage of the power supply. So this is an alternating power supply. This is the diagram representing the voltage, which graph shows the voltage across resistor R. Okay, now this is the positive cycle, this is the negative cycle. In option A, in option B, you have only positive cycles. Option C, you have half wave rectified negative cycle. Option D, you have half wave rectified positive cycles. अब ये कैसे मालूम पड़ेगा? So let's assume for this cycle, for my positive cycle, let's assume that top terminal is positive, bottom is negative, which means my conventional current is going to flow from here. Okay, it enters this junction. अब जैसे ये junction पे आएगा, it splits. So one part that goes from here. Okay, so again it can split. However, you see this, ये reverse bias cycle है, so it will not work. Same over here. This is the part where it had split. Again reverse bias, so it will not work. So I'll just erase them, which means the only possible path for my current to flow is this. Now can it go up? No, it cannot go back up again. Remember, current flows from higher potential to a lower potential. अगर आप वापस जा रहे हो, it means you're flowing back to the higher potential, which means this is the only path left. And again, this is forward bias, and this is how my circuit is complete, which means when my top part is positive, bottom is negative, my flow of current I will represent with a cyan color. Okay, I have some flow of current. Now if I go for the other half, let me write it with the red color. If I go for the other half, this half, I'll erase everything. Okay, now this is positive and the upper terminal becomes negative, which means now my conventional current will flow from here. Okay, it splits. One part goes here, but I know it cannot go because this is a reverse bias. So I'll just ignore it. Okay, now this is the path it takes. Forward bias condition, which will allow the current to flow. It will go up. It cannot go back. Why? Reverse bias diode hai, which means the only path left is again this. Okay, ye aa gaya niche. It has to go to the lower terminal. And this is how my circuit gets completed. Which means even in this cycle, bachas, my current was flowing from across R. Zara dekhiye how it was flowing. 1, 2. Yeah, it's still flowing in the same direction. Which means for both the cycles, my current was flowing in the same direction. That is from the top to the bottom. So for the first half, the cyan part, I had current flowing in a certain direction. Very good. This is out because यहाँ पे first half में current है ही नहीं. In the second half, when the direction of current changed, my direction of current across R was still in the same direction, which means from top to bottom. Which means my option B is correct because option A tells you that the direction of current will reverse, which is not happening. Option D tell you कि current होता ही नहीं है, which is also not the case because in both the cycles I am having current. Okay, I request you all to please go back to the start of the explanation, understand how this rectification works. Okay, then I move on to question number 34. So 4 small compasses are placed around a solenoid. A current is now switched on in the solenoid. This diagram shows the possible new direction of compass needle. Now, one way of doing this is using the right hand grip rule, identifying the poles and getting the answer. But however, itna mehnat nahi karna hai. You know that in this case, the solenoid will behave like a bar magnet, irrespective of where the poles are. Let's assume beta ye mera north hai, this is my south pole. This is how my magnetic field lines are. Correct? I'll mark it with the arrow, something like this. Okay, you know at the poles they will either be pointing towards or away, which is happening in all the cases. Very good, either towards or away. Okay, but I can ignore a few, or I can eliminate a few answers from here, a few options from here. Okay, see, this arrowhead represents the north pole. They both are pointing in, मतलब ये दोनों south pole है, which cannot happen. एक हमने eliminate कर दिया. I am left with B and C now. Okay, B, C and D. So A is out. A is out. Now bachas, look at the arrowhead over here at the central part. They both are pointing in the same direction, which means option B is out. Even my option C, look at how the arrows are pointing, the compass needle. One is pointing here, which is telling you here is the North Pole. The other is pointing here, which is telling you here is the North Pole, which means option C is also eliminated. So my only option becomes option Delhi, which tells you that my magnetic fields are in this orientation. Okay, so even if you don't know right hand grip rule, you can just use logic and solve this. So at the center, you will have magnetic field lines pointing in the same direction. That's why B is out, C is out, only D is correct. Now coming to question number 40. Okay, and looking at the graph, I can make out that there is some background radiation. How do I know this? Because the values are not changing now. Okay, so from here I can clearly say that my background radiation is Y. I can also tell you at t is equal to 0, my initial count is X. So this X is my sample along with background radiation count, right? Because every count that you have plotted will have some background radiation. So only my sample count becomes x minus y. Clear till here? So I know sample and BR is x, only background radiation is y, so only sample count will be x minus y. Now I need to find the half-life, right? Or the equation or the question deals with half-life. So sorry, the question deals with half-life, which means I know it is related to time taken for the sample to reduce by half, which gives me x minus y upon 2. I can write this as x by 2 minus y by 2. Correct? So this is my sample left. However, for me to use this graph to find out how much is the sample left, or measured count rate rather, at half-life, remember this graph has background radiation, which means for you to use this value, you will again have to add background radiation, because each and every value in the graph contains background radiation. So my equations become x minus y upon 2 plus background radiation is y. Solve this one please. Y plus minus y by 2, or y minus y by 2 gives you plus y by 2. It's like you're taking 1 and you're subtracting half from it, so you get half. Okay, so this is your final activity that it is going to measure, or the final count rate that it is going to measure, or you can write this as x plus y by 2. So your answer has to be Delhi. Okay, this cannot be the case because there is background radiation. This is straight away eliminated. This will not be the case. Now this is only sample at half-life, but the graph at every point has got background radiation, which means you need to add y to get the final answer, and thus the answer becomes x plus y upon 2. The same thing I believe I have told you all in my radioactivity video. Okay, but this is the mathematical explanation for it. I hope this video was clear to you all, and if there is any other question which you are finding difficult to solve, please either comment down or you can DM me on Instagram. Thank you.